This is geometry, section 12.2, arcs and chords. So we've already learned a little bit about both of these things, so this is really just a little bit of review and then a couple new theorems that have to deal with arcs and chords, which we already have learned about. So first thing that we need to talk about is a central angle. So a central angle is just an angle made by two radii. So these two radii right here, MA and AT, the angle that those make would be called a central angle. It's just an angle that goes to the center of the circle. A minor arc, we talked about this in the last chapter, minor arc is less than 180 degrees. Okay, so a minor arc is less than 180 degrees, so an example of that would be arc MT on this circle. A semicircle is half of a circle. Half of a circle, exactly 180 degrees, we know that as well, and a major arc is more than 180 degrees. Okay, another important thing about minor arcs and major arcs we use 2 letters always, and major arcs we use 3 letters always. So an example of a major arc on here would be THM, arc THM. All right, so use the figure at the right to fill in the blanks. It says the measure of arc PE, well, from P to E is 140 degrees. Remember, we measure arcs in degrees. When we're talking about their length, we would need to set up a proportion for that. All right, and then EA, this one right here, so from E to A, again, it doesn't matter which direction you're going, you just go in the direction of the letters. So from E directly to A, the shortest distance there would be 130 degrees. If I'm going from P to A to E, now I have to go in that order, P to A to E. So there's really 2 pieces here. There's this 90-degree chunk, plus this 130-degree chunk. So I have to add those both together. That gives me 220. Same thing with EPA. I have to go from E to P up to A. So I would add this 140 plus this 90, and that would give me 230. All right, a little bit more of the same thing, but now we have some angles that we have to fill in. We're not given everything. So the central angle here is 82, this one's 63. We can find this central angle here. So the arcs, remember, are going to be equal. The measure of the arcs are going to be equal to their central angle. So for example, NQ right here would be considered 82 degrees. So whether it's written on the outside like this or on the inside in the center like this, it's the same thing. So to find this one, for example, this chunk in the middle, we would add 82 and 63 together. That gives us 145. We would subtract that from 180 because these 3 together make a straight line. So this would equal 35 degrees. This angle up here is a vertical angle with 63. So this is also 63. And then to find this one, we can subtract 63 from 180 because these 2 together make a straight line. And then when we do that, we get 117. This is 117. All right, so now we just fill in the pieces. MRP, from M to R to P, well, that's half the circle. That makes a straight line, so that's 180 degrees. From Q to M to R, we've got a bunch of pieces we have to add up. So Q to N is 82, N to M is 63, M to R is 117. So we have to add all 3 of those pieces together, 82, 63, and 117. When I do that, I get 262. QR is just these 2 pieces right here from Q to R, so 35 plus 63 gives me 98. P to Q, this little chunk right here that we found, is just 35 degrees. M to R, we found this piece right here, we found that was 117. And P to R to N. So P to R to M is 180 degrees, and then if we go all the way to N, we have to add another 63. So 180, just do this right here, 180 plus 63 would give us 243. All right, so all of that's pretty simple, just finding your angles and adding up the arcs to figure out the measures of the arcs. Now we've got some theorems that deal with chords and arcs. All right, so the first one is this diagram right here. It says if 2 chords in a circle are congruent, we know they're congruent because we've got these tick marks on them. Okay, so these 2 chords, AX and BY, are congruent. Then their intercepted arcs are also congruent. So the arc, this arc AX right here, is the same as arc BY. They're the same measure, they're the same length, same everything. Okay, so if segment AX is congruent to segment BY, then arc AX is congruent to arc BY. They're the same thing. This next one, if the diameter of a circle, diameter, which would be AW in this case, so if the diameter of a circle is perpendicular to any chord, this right angle right here means they're perpendicular, so chord is PG, then that chord is bisected, meaning cut in half. We haven't had that word in a while. So bisected, so these two pieces are equal. And the intercepted arcs, so WG and PW, are congruent. Okay, so all of that put together, if AW is perpendicular to PG, then PE is congruent to EG. Those two pieces are equal because that whole segment's cut in half. And arc PW equals arc WG. All right, next one on the back. If a chord, so this is just the other one that we just had. This is that one backwards, the converse of it. So if a chord is a perpendicular bisector, so perpendicular bisector again means that it's perpendicular and it bisects it. So this chord right here, XY, is cutting this chord in half, AB, and it's perpendicular to it. So if a chord is a perpendicular bisector of another chord, then the first chord, this chord, is actually a diameter. Okay, so if we don't know if this is a diameter, but we do know that these two pieces are congruent, it's cutting this other chord in half and it's perpendicular to it, then we can say it's a diameter. And then the last theorem, if two chords are congruent, then the distances from the center to the two chords are equal. Okay, so if PQ is the same as RS, if these two chords are congruent, then the distance from C to A is equal to the distance from C to B. So we'll put 2 marks on those. Okay, so if PQ congruent to RS, then AC is congruent to BC. All right, so if two chords are the same, then they're equally distant from the center. And also remember from the first one that these arcs are then also congruent. All right, so find the value of the variables using the theorems. So we know that this is a diameter. It's going straight across and it's going through the center. So one of the ones we just learned is that it bisects this chord right here. So these two pieces are equal to each other. 2x plus 3 equals 19. Subtract the 3. 2x equals 16. Divide by 2. X equals 8. So x equals 8. And then we also know that these two arcs are going to be the same. So 80 would equal 4y. Divide by 4y, or sorry, divide by 4. And we get y equals 20. All right, for this next one over here, it says the radius of the circle is 12, meaning the diameter would be 4. Sorry, diameter would be 24. 2 times 12 would be 24. And it says AB is 2v plus 8. Well, the third one that we have, the one at the top of this page, said if we have a chord that's bisecting another chord and it's perpendicular to it, then this chord is a diameter, which means 2v plus 8 has to equal 24, 2 times our radius. So we subtract 8, divide by 2, and again we get 8 for the variable. All right, 2 more. Letter C. So we've got 2 congruent chords inside this circle. When we have that, we know that these arcs are the same. So we know this arc right here is 100, which means this one also has to be 100. So 2w has to equal 100, which would mean w equals 100 divided by 2, or 50. Okay, so even though w equals 50, this whole piece is still 100 degrees. we're going to have to keep that in mind, because now we have to solve for P, and we don't know what that is. We do know that the whole circle is 360. So far we have this 100 degrees, this 20 degrees, so that's 120, and then another 100 degrees. So total, adding all three of those pieces up, we get 220 degrees. We know the whole circle is 360, so if I subtract what I already have, it'll give me whatever this leftover piece is. So 360 minus 220 is going to be 140. So this piece equals 140 degrees. So then I set it equal to 5p, and I divide by 5, and I get 28 for p. All right, for letter D, last one. We know that these two chords are congruent because it says these are each 140 degrees, which means this chord is congruent to this chord because they have the same arc. So that means this distance is the same as this distance. So 2h would equal 18. So I would just divide by 2. H would equal 9. Then the same thing we did for the last one. 140 plus 60 is 200, plus another 140 would be 340. So if we subtract that from 360, we get 20 degrees left over for K right here.